Welcome everyone! This video is to present an executive summary of CANNIER, robotic lamination of composite parts. This solution has been developed in the Trinity Demonstration Program 2 with the aim of improving the agility of European SMEs in their manufacturing processes. After a short presentation of the consortium partners, we will go through the main aspects of the traditional production process at composite industries, then describing the main objectives and the results that CANNIER achieved. Finally, I will present the conclusions and the links for additional information on this use case. CANNIER involves three different partners: Robotics, which is the coordinator of the project and is located in Spain; STAM, which is the technology provider and is based in Genoa in Italy; and finally Composite Industries, the use case of the project, which is based in Zalău, Romania. Robotics is a Spanish SME with experience in the development of robotic and software solutions across several manufacturing fields, while STAM presents a strong background on European R&D projects, with expertise in developing tailored mechanical solutions and robotic cells for a wide range of applications. Then there is Composite Industries, the use case partner of the project, which is specialized in the manufacturing of high-quality carbon fiber components. Currently, the manufacturing process of CFRP parts is mainly based on manual labor due to the typical production of small batches of different products. Therefore, the high flexibility requirements are addressed by human operators, which are forced to perform ergonomic critical tasks. For these reasons, CANNIER aims at automating the lamination process of CFRP components, increasing agility, productivity, and quality. Moreover, the development of a new robotic solution significantly improves the working condition of the human operator. To achieve the goals, the solution is based on two main pillars: an accurate design of the lamination tools and the development of a CAM software for the generation of the robot trajectories. Two different tools have been developed to address the requirements of a wide range of different geometries. The cylindrical roller is responsible for the lamination of planar surfaces, while a spherical tool is used for laminating tubes or curved surfaces. The CAM software allows the user to define, layer by layer, the lamination trajectories, as well as the most suitable tool for the lamination. Therefore, the operator can directly contribute to the process with his or her experience. This video briefly shows a portion of the lamination process. According to the data introduced by the user, the software directly generates the robot program. Therefore, it accurately follows the trajectories previously defined, with excellent repeatability ensuring the manufacturing of high-quality products. Thanks to CANNIER, it has been possible to improve the lamination process of CFRP components, increasing productivity, quality, and agility. Moreover, it has also been improved the role of the operator, elevating his role as a supervisor of the process. Finally, the introduction of a robotic solution allows to reduce the overall manufacturing costs, as well as the percentage of non-compliant products. The CFRP production sector was chosen as application scenario in this project. However, the CANNIER approach can be also applied to different production environments, characterized by tasks with repetitive trajectories that may change with high frequency. The support of Trinity project has been fundamental for achieving the pre-established objectives. Thanks to the Trinity financial support, it was possible to develop the entire robotic solution. Moreover, the effective mentoring service for technical and administrative issues, complemented by the important support in disseminating the project achievements, has played a crucial role in the success of the project. To conclude, the goal of CANNIER was to develop an innovative solution for the robotic lamination of CFRP components. To have additional information, you can also visit the Trinity catalog by scanning this QR code. If you are interested and would like to have more detailed information, feel free to contact us. Thank you for watching this Trinity use case executive summary. Goodbye.